Yo, what's shaking, everybody? So we're here for another C lesson. I'm pretty excited. I hope you are. Today, I'm gonna go into while loops and for loops, and we're just gonna talk about how loops work in general. Um, and really, the first thing I'm gonna do is I'm actually gonna open up Paint, which, trust me, it's gonna sound actually, yeah, I will just use Paint for now. I have Inkscape too, which is a bit nicer, but I'm just going to open up this to show you a very simple idea in programming. So, obviously at times we want our programs to last a little bit longer. Like we want to repeat the same code over and over and over again, because you don't want your to have to write the same thing, the same if statement a million times. There's no point to it. It's silly. So instead, we use a thing called a loop. Loops are incredibly helpful. So loops are essentially let's just say this is our block of code right in here, little squiggly lines. And the way that a loop works is we'll declare the loop at the beginning, before this block of code is executed. And what's basically going to happen is when this is finished, we're going to come right here, and it's going to come all the way back around. So the way I like to look at it looks like this. It's like a loop. So this is the end statement, and this is the beginning statement. It's a bit of a crude drawing, but anyway, I think it kind of demonstrates my point pretty well. That like, oh, we have a condition, and we go through the code, and if that condition is met by the end of the code, then we leave. But otherwise, we go back to the top of it and we continue. And this is extremely helpful, and I'm actually going to show you why. So let's close this. I don't want to save it. Open up VS Code like I always do, and we're gonna write a bit of code. I'm gonna show you a thing or two. Pretty simply, once this loads, I don't know what's being so slow. Okay, so let's make a new document again. Lesson 4.c. Don't forget the .c. Very important. Wow, my computer's slow. There we go. I think VS Code's having some issues on my computer, I guess. So let's include our standard library, stbdio.h. Beautiful. Hang on, this is acting kind of weird. Let's close this and open this again. I like to have it in a way so it helps walk with me a bit. I'm trying to make this kind of like a free flow thing where I just kind of talk about it because I don't really like editing videos. Interesting why it's walking like this. Oh, oh. .h. How do you like that? And I think I might have typed this wrong. ST. Oh, there we go. Now it's all kicking in. Yeah, I always write this one wrong. It's STD. I don't know if it's STDIO or STBDIO. Now this C standard input output. We're just gonna Google it because why not? Um, really easy way to do this. Let's go to images. STDIO. Okay, so I was thinking the right the first time. It was just, I guess I forgot the name of it. All right, whatever. Let's keep on going. Shows you that I program in other languages more than C, I guess. But don't get me wrong. I still know a thing or two. So like always, we're gonna use our int main void. You don't have to put void there. I just enjoy it. Let's declare a false variable. Let's just go int x equals 10. Cool. So we got one variable, 10. Int y equals 5. Cool. So we have two variables. Pretty simple. We've talked about this a couple times now. You know, just declaring some integers, pretty simple stuff. But now I'm going to show you something new. We're going to use a while loop. And while loops, as you can see in this code, you put the code in here and the while condition. And when it ends, it checks the condition. Cool. It'll also check the condition as its first one, and if it's already true, it won't do this. So keep that in mind. So let's use a counting variable, because I think that's a very good way to use while loops. So let's go int count equals 0. Okay, so this is 0, and we're gonna want this while loop to run till count equals, let's say, 10. Cool. So this is gonna run until this variable equals 10, and what we're gonna want is we're gonna want to iterate this count variable each time, which just means we're gonna increase it by 1 each time, and that's what this plus plus sign means. It means to tell it tells the variable to increase itself by 1. Yeah. So now we have this code. Now it's not really gonna do anything, so let's put a printf in here, and let's see what happens, right? Because if I put a printf, it should print, in theory, 10 times. And if we go count, it should print it out every time. So let's try it. Let's see if this works today. So bizarre how that doesn't work. I'm gonna have to take a look into that. It annoys me because it used to just load it automatically, but that's fine. Let's just do it the old-fashioned way. Ooh. Cool. Okay, that's that. Let's open a new terminal because I don't know what's happening now. So we'll open this, we'll compile, and we'll run it. Ooh, it did nothing. Hey. So looking at this, why would this do nothing? Count equals something. Printf is like that. Now, do I need to answer? Man, I am tired tonight, I guess. Oh, you know what it is? It's because I said while count equals this, and count doesn't equal that, obviously. So it should be why it doesn't equal that. And I don't know if I explained this in the last video, but when you put an exclamation sign, it's just like saying not. This does not equal that. So there you go. That's another helpful sign. So now when while count doesn't equal this, this will run. So simple mistake, make it sometimes. And we run this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's what we want because buddy, the first time this runs, it'll go, oh, count equals 0. So it's like, oh, does count not equal 10? Absolutely. And it'll print that value. And each time count prints this value, it'll go up by 1 because it's iterated each time. And as you can see, 10's not on here. And the reason for that is because when this equals 10, this isn't true anymore, so it wouldn't execute this code. But let's do something a bit more interesting, because that was cool. It was cool. You want something now, but let's use x. And let's say each time this runs, x equals x plus y. Right? Pretty simple. And let's see what happens. 15, 20, 25, and it's iterated, and it goes up by 5 each time because we're adding this. And that's basically a while loop. You can add whatever code you want in it as many times as you want. It's pretty simple. I don't know why I dotted over that so much. So let's move on to the next type of loop. This loop is similar, but as you can see, there's a whole lot more going on in here. And in fact, for loops are much more useful, in my opinion at least. Depending on what you're using it for, but it's handy. So if you look here, we have a beginning part, and in a for loop, it actually gives you the option to declare variables in the condition line. So let's go int, just call this count, right? So boom, we got a count variable equals 0. And then right here, it's the same kind of deal. We can go, when count is, let's put 0 here, and when count is bigger than, let's go 10. Let's go 10 again. I like the number 10 today. And we'll go put count here. So let me explain this in better terms. So this beginning part is a variable declaration area. So if you wanted, you could go w equals 20. And you got to put Oh yeah, and there you go. So you can put as many ints or whatever you want here. And that's pretty helpful. So you can have as many iterators, or you can even use these variables within the code. Now, you don't want this to be in too cluttered, but it's pretty helpful. You get your variable declaration. The middle part is it's basically the quick condition of a while statement. So it's like the while condition, while this is true, keep going. And then this is the iteration counter. So you can put whatever addition you want here, but typically it's used to increase this this measurement right here. And we use that measurement. It's like this is a measurement of how long it will run normally, and this is a condition using that variable to check when it's done, and this is a thing to add on to that variable. And it's actually, if you look at it, it's very similar to a while loop, but it's all in just one line. And that's what's beautiful about a for loop. It's all a bit more condensed, a bit nicer. So we'll do the same thing as we did for the, I'm sorry, as the while loop, we'll print, we'll just go like Control D, and we'll go X. And, I'm going to show you another new thing today. Go X plus count. So this is another thing you can do. You can just add stuff or multiply stuff within this as many times as you want. And you know what? We're going to get even a bit more interesting. We're going to multiply it. Because what this does is this actually doesn't change the value of the variable. It just changes the value that's displayed here. So I'll show you that right now. Implicit declaration of function printf. Oh, sorry, spelled, oops. There we go. Yeah, that's a simple error. And we'll try this. Now why doesn't it print? Let's take a look. Is 10, see now I got the sign back. 10 is greater than count, right? And count's less, so it's got to be the opposite. Let's go 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. And you might be wondering why it's increasing like that. And the reason is X isn't being changed, count's being changed. So each time it goes up by 1, it'll multiply this by a higher number. So starts with 0, so 0. And then it goes to 1. 1 times 10, 10. 2 times 10, 20, etc., etc., etc. And that's the idea of loops. And as loops go, you can put an if statement. You can do a scanf to continuously ask questions. You can do other stuff. Now, an interesting thing is in this, we have a very helpful command, two commands actually, continue and break. So these are very simple. Break basically just means exit from the loop. Right? That's what I like to think. It exits from the current part of the code you're running in a loop. Continue does not that. It basically brings the code from the continue. It basically restarts the for loop, but not the iteration. It'll just bring the continue. It'll just make you start the code at the beginning of the loop down again. So restarts code block in loop, and it's very helpful in certain situations. Because say if you had like gibberish here, bunch of extra code, and you only want it to run in certain cases, and you have an if statement here saying whatever, like you have an if here, and if this if happens, we want this to happen. You could just use continue, and you could go back to the top instead of having the one or this other junk that you don't need. And yeah, that is for loops. You got break, continue. You got to know your stuff inside the for condition. So you got to know the iterator, the condition, and then you have to know what you're going to increase it by, or what you're going to multiply it by, or whatever change you want to make to this number that you're iterating, right, in some kind of way. And yeah, that is loops in a nutshell. Not too complicated, not too long of a lesson here, but very important. We'll actually be using these quite a lot. And again, if you want to try this out, maybe make a little calculator. Just get two ints. See if you can scan them into a computer by putting a scanf and have a printf saying, "Oh, enter a number," and then you get a scanf, and then you another one that says, "Please enter your second number," and then you put a printf statement where you add both of those numbers together and you print it out. And I highly recommend you try to do this using this method where you add them inside a printf. So it doesn't require you to save it to a sum function. You only need two variables. And yeah, so try doing that. Shouldn't be too difficult. And yeah, thank you for listening to me.